Welcome to the Cinegy Route 22 webinar, the first Cinegy webinar of 2023. I'm going to be doing a quick catch up and headlines on what's happening with us since the last time we spoke. I'll be talking about what Cinegy Route actually is. It's a well-kept secret, I say. It's a fantastic piece of software, but people don't tend to see it because they don't really understand what it does. And I'm hoping to change that with the webinar today. Particularly, I'm also going to be talking about the new Cinegy Route, which is a quantum leap forward from the old Cinegy Route, which was already, in my opinion, pretty amazing. I've been very happy with it over the years, and now the new version's even better. We're going to be showing how Cinegy Route integrates with other Cinegy apps to make handling IP video very easy, and I'll be showing off how it works. Excuse me. I'll be showing off how it works at the end, so you can see that everything I've told you is true and accurate. So firstly, let's talk about the catch up and headlines. We have latest versions of a bunch of our apps up now. We had a big flurry of releases around the new year. And so as of right now on the website, the following versions of everything are available. 2212 release candidate is close to perfect. We've got customers using it already. It will become an official release in a few days, or maybe a week or two. It was right on the cusp of that, losing that RC status and becoming a full-on release. If you grab it now, it's going to work for you. Ditto, Cinegy title. Note, Cinegy title, not titler. We've changed the name because we're going to make some changes to it. Give it a new name so that people understand the difference between this and the old one. Capture is also at 2212 RC. Is it 2210? Anyway, convert at 2212 RC. Desktop at 2211. Archive is coming. It's not yet there, but 2211 will connect happily to Archive 15, which is the current version. Multi-viewer 2210 RC3. This really is ready to pop. And of course, 2210 Cinegy Route. The other headline for this particular webinar is to mention that we shall be at NAB this year again. In the North Hall this time, rather than the South Hall, which is our usual haunt, and the Central Hall, which is where we were last time. We'll be obviously sending out mailings and everything, telling you where we are if you're going to be going as well. But yes, we will be once more present at NAB. So then, let's ask the question, what is Cinegy Route? Okay, so, excuse me, as all of you are no doubt aware, if you want to transmit video, you can use video cables, HDMI or SDI or whatever it is, or you can encode it into a network stream and just send it down a network cable. There's a whole bunch of good reasons for doing that. You can get a whole load of signals on one network cable, for instance. However, in order to make this work, the signals have to be identified, and they're usually identified by URIs, which some people just are completely comfortable with, and others find them just confusing. So Cinegy Route allows you to take these IP streams, use one URI, excuse me, use a URI to identify it in the directory, and then thereafter it'll have a name that you can simply look for. Much easier than messing around with RTP // at 239 radova. So that's the first part of it. It makes the signals easy to identify. The second part of it is that it gathers them all together for you into a neat directory, from which you can then immediately identify what you want and where you want it to go. Its inputs can be either SPTS, single program transport streams, or multiplexes, MPTSs. We can take the multiplex straight into Route and break it out, and we'll be showing you how that works in the demo. But it means all you need is one IP address from your source, satellite transponder, terrestrial transponder, wherever it is you're pulling this stuff from. Read the MPTS into Route, and it's all opened up and laid out for you to use. The channel directory, it makes it possible to group the channels according to how you would want them to work for you, and allows you to name the channels the way that you would like to name them, or the individual signals will take their name from the incoming stream. There is access control as well, in that any signal that you pull into the route is automatically blocked from being viewed until you release it. It's a good way to ensure that unrequired or unsuitable or whatever content isn't immediately put out on the system. You must actively enable access in order for the signal to be useful. Otherwise, well, it's just invisible, it's not there. Straightforward, simple previewing, little preview players that will pop up to show you the currently routed stream, a stream you want to change to if you like. The player now has a mute button on it, which is nice. And then the final thing that you can do, or not just the final, in fact, there's a bunch of other things. This is just basic things here. But another thing you can do is signal processing. You can pull in the video from one stream and you can you can replace the audio track with the audio from another stream. And you can also adjust the incoming audio if at the transmission side there is synchronization issues. You can tweak it at this end, so you can do some signal processing with it as well. So to give it all some context, the RTP standard has been around now for decades, and provides a standard for the encoding of video in a way that everybody understands. Uses standard transport stream structures with streams and PIDs and everything that we are all familiar with. And it's been around, as I say, for some time. The strong argument for me is always the video over network cables. One single network cable can carry hundreds of video signals, one single cable. So why have a bunch of purple spaghetti? You don't need it. You're using straightforward computer systems for IP, ordinary switches, ordinary servers, ordinary NICs. Obviously, since it's a network protocol, the faster you go with it, the more possibilities there are. But at the end of the day, it's straightforward standard computer systems that you're using here, rather than expensive custom things with those crazy expensive BNC connectors and all that stuff. People tend, however, to look at RTP and UDP with suspicion. Traditional broadcast engineers don't trust it, and they don't trust it for a bunch of reasons. One of them is a constant thing that we hear is, well, yes, but it's for compressed signals, which of course isn't strictly speaking true. But the broadcast engineers' complaints against compression have been losing their worth over the last few years as compression becomes more and more standard. If you're using a recording made on a Sony camera in UHD, it's compressed. Compression is in line all over the place. You have to live with it. To object that it's compressed, not going to fly anymore, and not going to fly for years now. Legacy plant. People spend a lot of money on SDI equipment, and it's excuse me, and it's in there and it's working and so on and so forth, and it doesn't really matter until the stuff starts getting old and the service fees start going up and so on and so forth. But the cost to replace SDI systems with PC systems, given the lower cost of cabling, etc., 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 it's a lot cheaper to replace it than you might think. And then there's the latency thing, and its cousin, the synchronization thing. The latency thing is a tuning issue. we can get down to 10 milliseconds. So that's, yeah, not instantaneous. It's not real time, but it's pretty damn good. And SDI also has lag, and you see it. It's a configuration issue, and it can be avoided with careful setup, fat networks. It's not as much of a problem as people think. This is why we still hold to our battle cry of SDI must die. There is still a demand for baseband out there. I know there is, because I'm talking to people every day about it, but piece by piece, it's crumbling. And as we move forward, we will see more and more that there are solutions outside of purple cables for managing your video signals. And that's what Cinegy Route is all about. There are things out there that people call IP video, and they call it that to get people's money. But it doesn't match the IP video that we're talking about. Our RTP UDP based systems are based on published open standards and conform to those standards. And if you want to see what those standards are, all the RFCs and all of our documentation is all out there and it's available. The SDI industry, and there is an SDI industry, of course there is, all the cards, all the cables, they'll come from somewhere. The SDI industry saw this IP thing coming, and they thought, well, hang on, if it's all about regular network cards and it's all about regular network switches, where's our added value? This is, you know, they've shot our fox. We're stuck here. So their response was to come up with something which they call IP. And if you go Googling it, it'll turn up, Googling IP video, it'll turn up in searches and what have you. It's got nothing to do with R2P and UDP. It's got nothing to do with us. Although, if you have a need for it, we will support it for you, but we don't believe in it. So ST2110 is what they call IP video. It involves sending extremely large amounts of data over your network cabling. It requires high performance NICs or dedicated cards, which will cost you a huge amount of money if you can actually get one. It is complex to set up. It is a closed system. It's IP in name only, and the point is that we, using our internal codecs, can give you an HD signal, cleaned up and beautiful in 150 megabits, right? So 10% of the full SDI stream. ST2110 works on trying to cram those streams into your network, shovel a whole bunch of pixels down your throat that you're never going to use or never going to see. The whole thing has to be built up to handle all this high-speed signaling, because it's using huge bandwidth to communicate the video, and that's not necessary anymore. So we don't believe in it. As I say, there are people out there who have been using SDI and think that's the way forward. It ain't. Certainly it doesn't count as IP because it's not open, because it's not using standard computer systems as we do. NDI is an interesting thing, because initially we were a little, how shall I put it, suspicious? No, that's not the word. Cautious, because we didn't know if it was going to take off or not. We had a lot of customers asking for it. Eventually, when we saw that it was there and it was mature and it was starting to do the right thing, we built it into our systems. So the thing to bear in mind here is that we don't have any way of looking into NDI's packets. NDI, we have an SDK for to allow us to implement it, and that allows us to see the signals, pull them in, do stuff with it. We can work with it, but we can't use it in Cinegy Route because we can't get in the packets to do stuff. That doesn't mean that, again, doesn't mean that we don't support it. In a particular case of NDI, there are cameras and all of a sudden this means we can look at a complete studio system without a purple cable in sight. So we have to support that, of course we do. And it does have its uses. We do have very happy customers out there using things like Live View and vMix. But it's over the network, yes. Multiple signals, yes. Not IP as we understand it. To put it all into context, we've been doing this stuff for a while. We're now in our third decade of IP. Certainly when I first joined Cinegy a number of years ago, and I would be talking to people at trade shows, broadcast engineers, that their eyes would glaze over. They simply didn't get it. They didn't grasp it. But at the time, it made sense for us. I had customers interested in rebroadcast, and going through IP made rebroadcasting a very straightforward proposition. We started with what we called the IP tools, which was a suite that included route and multiviewer, and later gained the stream switcher. And these things were all gathered under that one banner, and they all got the yellow logos that we now use for them. And over time, they were integrated into other applications. We decided to break out those applications and separate them into different ones rather than putting it under the one IP tools banner. This happened, gosh, 10 years ago. And so now the multiviewer and route and stream switcher are offered as separate discrete applications, all integrated into the apps and workflows that we use. Today's IP tools setup, today's route allows for things like event triggering and hardware offload. And right at the bottom, with 2 exclamation marks, SRT. This is extremely important at this point. SRT really does bring Cinegy Route into the forefront. Those of you who've been those of you who've heard a couple of my other webinars will know I'm very up on SRT. I think it's an absolutely astounding piece of technology, built out of a combination of the standard UDP method of video transmission, combined with forward error correction and changes in the way data is transmitted based around high-speed studies that were done in Chicago about 20 years ago. SRT makes it possible to have, as High Vision themselves say, the best video from the worst networks. Okay, so even if you have a crappy connection, SRT can negotiate to get the best possible picture out of it. If you have a good connection, then SRT is extremely tunable. And by being extremely tunable, it means that as long as you have network bandwidth, which is actually getting to be a cheaper and cheaper commodity, then you can broadcast your video via SRT from site to site via the public internet. And all of a sudden, a whole bunch of possibilities open up. Distribution and contribution are 2 examples. Contribution we've already seen 2 years ago, or just over 2 years ago, the inauguration of President Biden in America. We had a news customer who had reporters in the crowd in Washington, DC, doing impromptu interviews with people with their phones. They would then send that through via SRT from the phone to New York, where the stuff was assembled, put together, captioned, and so on, and then broadcast back, sent back rather to the home country for broadcast. So you can do contribution using SRT in all sorts of spontaneous ways. Distribution is another one. I found out just exactly what it costs to transmit over satellite, and it made my hair stand on end. But with SRT, you don't need a satellite. And in fact, if you've, again, if you have control of the bandwidth from site to site, you'll get the video quicker from another location than you will from a satellite, because you don't have the 35,000 kilometers and back loop. So it's perfectly possible to do distribution as well using SRT. So all of a sudden, Route is has the possibility of like rebroadcast management and so on and so forth, but it also has the full-on possibility for production use, as long as you're working with IP rather than baseband. I mean, amongst the other little things that you can do is it's perfectly possible to accept a video signal via a wireless connection. Normally RTP and UDP don't like wireless, but SRT will allow you to use it. So from an infrastructure point of view, contribution, distribution, there's a great deal of potential now with SRT, and as SRT is built into Cinegy Route. So then, the new stuff. First off, just out of the release notes, SRT, as I've already mentioned, it has a bunch of things. One of the things it's got is open SSL encryption, so you can make sure that your stream that you're sending from wherever to wherever it goes can't be sniffed and messed around with by anybody else or shown where it shouldn't be or whatever. Simply put a passphrase in when you send it out, share the passphrase with the destination, and you're good to go. We now have, it's all now in 64-bit. It's been 32-bit forever, but now it's all been moved over to 64-bit, which is obviously a great increase in potential and capacity and so on. Not that I ever banged my head on limitations, but wherever they were, they're now gone. Massive is a good word for it. The UI and UX enhancements make it a lot easier to use than it was. And they are definitely 100% features that now that they're there, it's like, wow, how come we never had them before? So very good step forward in that sense. Cosmetic things like supporting high DPI mode, suddenly everything looks better. HEVC support is now there in the preview player for UHD. Also via GPU decoding, you can take weight off your CPU. The Cinegy Route player mute option. Oh, how long have I wanted that? I'm pleased that it's there. It makes life a lot quieter. There is also an always on top option, which allows you to keep an eye on a particular stream in the Route browser, and browser, etc. I'll be explaining in a second. And the possibility of triggering secondary events from Cinegy Event Manager to allow you to, well, the secondary events that you can trigger with a Cinegy Event Manager are on the one hand to do with hardware switching, GPI, whatever. And on the other hand, a secondary event can be a PowerShell script. So pretty much the options are limitless. But essentially, on switching the source, you can trigger another event to do another thing. This is a fantastically useful new feature. So what's in Cinegy Route? As you can see here, there are 4 elements. No, wait. There are 4 elements, but one of them I haven't bothered putting up here because, well, I'll explain. The first thing is the Cinegy Route Manager. The manager is what you use to pull all your input streams together, sort them out into the different folders that you want, and set up your virtual destinations and processing nodes. Also from Route Manager, this is where access control is configured, because as I mentioned already, any incoming signal will automatically be withheld until you release it. So what virtual destinations and processing nodes are, I'll be coming back to, but that's what you do in the manager. Control allows you to take the structure that you've built in the manager and make use of it. So it's your router panel. You have your incoming streams and you have destinations where those streams can be sent. You can also make use of the processing nodes that I mentioned last time, and I will tell you about in a minute. But the control panel is the actual router itself. And then for general purpose use, we have the browser. The browser is exactly what it says it is. It will show you your incoming signals as from the directory tree, from channel manager, and it will allow you to click on those and see what they're doing and preview incoming streams. And it will also expose the RTP address. Sometimes it can't be avoided. Sometimes you will actually need the RTP address, and the easiest way to grab it is just to open Cinegy Route browser, click the channel you want, and copy the address. We'll be seeing that also as we move forward. The fourth element that isn't on the list is a bit of background stuff, effectively an intermediate server that you can build in if you are working with thousands of channels. Sometimes if you have a great deal of estate, it's necessary to broker communication from Route Manager to all the various endpoints. And the channel relay service essentially does that. It basically checks for all the endpoints and refreshes them as needed. But since there's nothing to show, and since it only becomes relevant when you get into thousands of channels, I haven't bothered including it other than to mention it here. But it's one of the things that makes Route so scalable. As with all of our software, it's all client server. So these three elements that we're talking about here are visible on client machines, which can be the same machine as the server if you want, no reason why not. But they will connect to the directory server wherever it happens to be hosted. In the demos, we're using my machine because it's on my machine, but you can have a central server, and it's to be borne in mind that these applications we're looking at here, the manager, the control, and the browser, they're the only ones that actually use any kind of CPU. The channel relay service is only switching packets and it weighs absolutely nothing. So if that's just running on your server, it can run on any server at all. It really doesn't need anything powerful. So let's have a go. I'm going to walk through and point out all the bits and pieces. And before I fire it up to show it off, this is the main interface of the Route Manager. The folders are on the upper left. These you create in order to store your signals. This is my rather chaotic setup because I just add stuff and I don't necessarily remove it. And yes, well, it doesn't have to be chaotic. You could actually make it tidy, and maybe I'll do that one day. Here, but in any case, here are the folders, the virtual destinations, excuse me, and the processing groups. Preview window underneath, with its mute button now visible. Excellent. The inputs are here. In this particular case, the input that I've highlighted is an MPTS with 13 channels on it, one of which is radio, but we won't worry about that. So 13 channel multi-program transport stream coming in, and underneath we can see all of those channel the streams out of that one MPTS, all laid out nicely for us with their PIDs and IDs and everything to work on. And yeah, so whoops, yes, going to the next part, the virtual destinations. Here we have, again, we can group these into folders. I have a folder called MV30. MV30 is a 30-screen multi-viewer that's fed by two transponders, one on Astra 28 and one on Astra 19. And it means that I can have a multi-viewer where I can, whoops, come back. Racing ahead of ourselves here. I can have a multi-viewer where every single screen is configurable from outside, so that if I need to change channels, if I need to share a heavens help, if I need to change an input channel, I can do it via the router without having to call up the multi-viewer configurator and restart the multi-viewer. Essentially, it will change the input stream on the fly for you, so your multi-viewer is always up. Simple, really. I think that multi-viewer, if you're in an IP environment, multi-viewer and root belong together like coffee and cream, but there are plenty of people out there who don't take cream in their coffee, and there's plenty of people out there who don't buy root with their multi-viewer. But it's nonetheless, it does make working with multi-viewer much more flexible. And not just multi-viewer. These have been set up for multi-viewer, but they're not restricted to it, and I can use them anywhere I like, as we will be seeing. And again, we have the preview screen. Down at the bottom, in the corner, we can see the bottom left corner, we see the word localhost. That tells us this is my server that's running on my local machine. Finally, the last part of the manager is the processing groups. This is meaningless until you see what it does, but essentially the way it works is this. Again, we have the folders and the preview and the URI are all here. If you look at the URI, you'll see it is in fact an HTTP URI with a funny port, and this is because this is our virtual destination. And this is what it looks like in the outside world. It's a web link that we use to connect our signals excuse me, with our endpoints. We can see the access control setup here insofar as the processing source, when I start it, has the visible to button. If I don't open that up and make it visible, no one's going to see it. So this is how the access control system works. You'll see the object will be visible for the following users and groups. This means that in your, for example, Active Directory environment, you can create a group to restrict this to, such that other people in the AD won't have access to it, won't see it. Or in this particular case, it's just opened up to everyone. But from here, this provides you the hooks to use your Windows server to manage access to the content. So that's the three parts of the manager. Now we come to the root control. Again, folder browser, preview window. Here we can see the processing groups. If we go back, the processing group is just a name. There's nothing to it, just the same as the virtual destinations, also just little, it doesn't say anything. It's only when you run root control that you can see here are the virtual destinations. Excuse me. And the virtual destinations, I can simply drag and drop from any one of these onto a virtual destination, and it will route it. It will ask me if I'm sure, and then it will route it. You'll see this in a minute. Oh, sorry, hit the mic there. You'll see this in a minute. And underneath, you see also the processing mode, processing node with a N, and this time it's got a bit more detail to it, so as to what you can do with it. So in each of these cases, we can see the channels that have been routed in here by their names, which route automatically pulls out of the streams. So you can drag and drop, or you can hand insert, whichever way you want to go into the virtual destinations. This is showing virtual destinations and how they work. So in the preview, here we can see in the preview channel, we see one channel, Togo Plus, down, that's at the lower left there with the blue sky. And if we're going to consider changing that stream, then it'd be nice to see what we want to change it to, and we can do that excuse me, with the browser here, which pops out, which allows us to select a different source and see what's on it. Is that the one we want? If not, we select a different source. If it is, we hit OK, and the route will take place. So all nice and clean and tidy. You can see what you've got already, and you can see what you want to put in there. It really is as simple as that. Drag it and drop it, or pop it open with the properties and change it, and your routing has happened. Processing groups. Okay, so with processing groups, we can take a video stream or an audio stream, and we can add other audio to it, or we can remove the audio, or we can move things around. In this particular case, we've got the source choosers visible there on the left, and again, a preview, which is not running because I'm not doing anything in a minute. On the primary audio, we have 4 stereo pairs marked, M1 to M4, although usually the audio is just on M1. I can tick M1's primary audio out and tick secondary audio on the M1 on secondary audio. and then the video will have the secondary audio playing on it. In addition, here we can see the synchronizer, which can also be used simply to compensate for a delay in the system. And then we'll set for the rest, it's standard mixer sliders, mute left, right, and solo buttons. Yeah, so very, very basic, but you can use this to clean up an incoming audio if it's coming in too loud, or you can use this to add a different audio track to an existing incoming stream. All sorts of things you can do. But that's the processing group. Finally, we have the Cinegy browser, and it's just no more complicated than this. The channels that are available to you can be viewed in the screen underneath. The URI at the bottom can be copied and stuck in somewhere else if you need a URI for something. And for example, I can give an example of how the URI thing would work. And that's with Cinegy Air. With Cinegy Air, your single live input, you don't have a browser possibility for that because it's your single live input and you're not going to be messing around with it. So if you were to have a standard live input coming in as an RTP stream, you could copy that and put it as your default live input, and away you go. So that's what that's for. And it's indeed other places where you might need it. But dear listener, it doesn't have to be that way, and we'll be seeing that in a second. So really nothing more to say about the browser. Put it on anybody's desk and they can see it all the time. Click the always on top button and they can be seeing their stream, even if they open Excel on top of it. Here are some examples of integration with Cinegy apps. We'll see this live in a second, but Cinegy Air, there's that browser. Cinegy Multiviewer, there's that browser. Cinegy Capture, there's that browser. So to pull any IP signal into these apps, it's just all you need to do is clicky, clicky, clicky. As simple as that. All right, so let's have a demo, shall we? Let's close some stuff down on the desktop so we can see what we're doing. Okay, so what we're looking at here right now on the desktop, I have, as the observant of you will have noticed, I have four incoming channel, four channels of air working at the moment. I have 2 incoming MPTSs, one from Germany and one from the UK, and this allows me to have a multi-viewer that looks like this. Okay, ooh, I'm into performance issues here, but that's my 30-screen multi-viewer. So how did I make my 30-screen multi-viewer? Well, it all came from Route. So if I go to my multi-viewer configurator and start that up, then we will be able to see that in the multi-viewer configurator, excuse me, and here it is. And I have put all my virtual destinations into the multi-viewer configurator. Here we see the weird HTTP URI in the center of the screen, showing that this is a web connection for us to stream video to. And yeah, if I wanted to find it, just click the button and up it comes. And I can change around my virtual inputs if I want, or I could switch to a direct stream if I wanted to, which I don't. But it's as simple as that to pull these things in, and the signals are directly available then in multi-viewer. If I'm going to close the dashboard for 1 second. Oh yeah, one more thing to mention is here in the Cinegy browser, I said I've got 2 transport streams coming in, 2 multi-program transport streams, but that's not my only video source. Those of you who know us well will be familiar with this footage, Mumford and Sons from Glastonbury about 12 years ago. What you won't necessarily know is that this perfectly crisp, beautiful 1080 video feed that we're looking at here is coming into my system from Nuremberg in Germany, which is 1,000 kilometers, or give or take, or 600 miles from me. All right, this is coming across the public internet, and there is absolutely nothing wrong with it. So this is an example of a remote signal being pulled in via SRT, and this could be coming into your facility, and you can be doing what you like with it, and you can also send your signal, and it will come nice and crisp the other side. But this is full HD that's coming down a telephone line. It's coming down a public internet connection. So that's all of my signals together. I'll just tuck that down for a second and close this for a second. If I bring my multi-viewer back up, oh, that's there we go. So here's my multi-viewer now. If I just pull it down a little bit, we can see here, for example, here's my SRT feed in here. The other ones are SD feeds from various channels in the UK and in Germany, specialist channels, national channels, etc. If I wish to change a signal, let's just for fun, let's go to the UK and let's put one of those UK channels up at the top here. So let's go to GEMS, and we'll move that to here and hit yes. And now we'll see, there we are, it's changed. This is now the GEMS channel, and as simple as that. Just drag and drop for any one of these, sort them out how you like, and drag and drop them to fit. If I go to the processing node, this is where I could make some changes if I wanted to. I could select an input source, again straight from the browser, okay, and I can pick a completely different input source, okay, and now from here I can change it so that just by doing this means that now RTL will go out with Nitro's audio on it. Or if there's something wrong with the audio, I can always fix these things just by hitting reset. Will reverse any changes that I've done. It's a specialized tool. I think it was done for somebody originally for specialized purposes, but it's very useful and it's there. So this is route into multi-viewer, which is, you know, kind of obvious, kind of a no-brainer really. If we instead we can look at something else. We look at route going into, yes, let's close you. Let's look at route going into air. So if I configure this air channel, we have our standard input. Now on this one, I've set that standard input to my SRT input. What's on this one? I think. So I'll go to channel 2. There we are. Now I have used a route link that I copied from the browser, but that's all I had to do with it. I didn't have to try and type it in and look out for all those pluses and colons and equals. I just copied it and put it in there. And as said, there's no browser here because this is intended to be a static input. But if I go to, I think it's this one, this is where we'll see how good I am. Did I remember this correctly? No. Maybe it was this one. Yes. So here, oh look, my input, excuse me, my live input is now one of these weird virtual destinations. So this means I can, in fact, switch my live input from outside. Now, this has always been something, you know, if you had a baseband live input going in, you switch it from the router, boom. We now have the possibility of doing exactly the same with an IP signal. So I can set my default live input using a virtual destination. And then if I drag, so I'm using, yeah, RTL here, MV31, sorry, RTL regional. But I'm using that. This virtual destination here is the input for that air channel. So in fact, I was a little hasty closing my dashboard. So let's just pull it back up. And that's the channel at, so that's this one here. Channel number 2 is coming from here. And so if I do what I did just now and change that here, then you'll see channel 2 change. There we have it, changing in air. So my standard live input, the one that's in air when I hit go to live, can in fact be an IP stream that can be changed for you. And if I just go to up to Germany, I can put it back the way it was just by doing this and say, let's put this here where you can see it. So there's Gems TV, and we'll just put the German signal back just by hit yes, and there we go. The German signal is back. So that's one part of integration with air. Another part of integration with air is in the playlist. So here we can see an incoming, we can see a live stream in playout, and we can see an incoming live stream in preview, setup and queued as in pink and yellow as we know it in air. If I say I'd like to insert a live item, then I simply go to my live item here and go to properties and parameters, and now here I have my browser and I can select my next live input from my browser, and so I could take it from a multi-viewer input, or I could take it straight from a physical signal, because I've got them both available to me here. So go to the UK, go back to Gems, it's easy to spot, and I say okay. Then we'll see the Gems TV now is our input feed. If I queue this one, we can see we have the other input feed also. So mix and match your incoming live feeds directly as program items and control your IP input stream into air using Route. And that's pretty much all I wanted to show you. Thank you very much for joining me today. Any questions or demo requests or anything like that, just pop them to sales@cinegy.com, where I will be, or one of my colleagues will be happy to answer it for you. I hope you've enjoyed it. I hope it's been useful to you. Thanks once again, and I'll speak to you at the next one. Bye now.